Continuing with the theme of survey data analysis in Stata, we're now going to look at an example of a cluster survey in Stata. So recall we have this hypothetical country of Inventia. Now the first thing we did is we went in and we just took a simple random sample of size 1,000 from this population of 500,000. The next thing we did is we broke the country up into provinces 1, 2, 3, and 4. And we took samples of size 250 from each province for a total sample size of 1,000. And recall that in order to be able to do that, we needed to know the population size within each of these 4 provinces. Now, rather than breaking things up simply by province, what we're going to do is there's 146 different districts in Inventia. So pardon my drawing skills, but assume that each of these little boxes represents a district in Inventia, and assume that there are actually 146 of those in this picture. Now we're going to have 2 stages of sampling. In the first stage, we're going to go in and we're going to select 25 different districts. We're going to randomly sample those. So just at random, we choose 25 different districts. And then within each of the sampled districts, we're going to zoom in on this one district. You've got people that live in those districts. We're going to go in and we're going to randomly sample 40 people per district. Obviously only sampling from those districts, those 25 districts that we've sampled, that we chose in stage 1. So this is now a 2-stage design. It has 2 stages of sampling. And again, it's an example of a cluster sampling survey. Okay, so we've got our survey design. We're randomly sampling 25 districts, and we're randomly sampling 40 people per district. We could have used different methods to, say, sample these districts. We could have sampled them with probability proportional to the size of the district, etc. We're going to go a little bit more into that on the homework assignment this week. But for now, just assume that these 25 districts were selected using just simple random sampling, and these 40 people were selected using simple random sampling. So what fraction of the districts are we sampling in our population? We're sampling 25 out of 146 total districts in the population. So this guy is actually going to be our finite population correction in Stata at stage 1. And then what fraction of the population are we sampling at the second stage? The second stage we're sampling 40 out of however many people live in that district. And we'll call this FPC2. It's our finite population correction at the second stage of sampling. And notice that in our denominator we have the population size in the district, so that's actually going to change. It's going to be different for each district. So now let's think about the probability of a random person, say Joe, who lives in District 4. Just any random individual who lives in a given district. What's the probability that that guy gets included in your survey? Well, to calculate that probability, we have to think back to conditional probabilities. See how it all comes together? So the first thing we didn't know is what's the probability that District 4 even gets sampled? And then we multiply that by the probability that Joe gets included, given that District 4 is included. And so I have the probability that District 4 is sampled times the probability that Joe is sampled given that District 4 is sampled. And we know that this should just in generally be the probability that Joe, who lives in District 4, gets sampled. This comes from the stuff we learned in week 3. So the probability that District 4 gets sampled, it's essentially just this 25 over 46 since we've used random sampling. The probability that Joe, who lives in District 4, gets sampled is just simply 40 over the number of people in the district since we've used simple random sampling. So to calculate this probability, we just multiply the 2 finite population corrections. And to get our survey weight, we invert that. All right, so we figured out our 2 finite population corrections, and we figured out how to get our survey weights, so now we can analyze this data within Stata. Go ahead and open up the dataset cluster.dta. To survey set cluster data, we first need to define our finite population corrections and our survey weights. Our first finite population correction is simply 25 over 146. Now we generate FPC2, which is going to be 40, the number of people sampled per district, divided by the district size. To get our survey weights, we multiply and invert the two finite population corrections. So we would say generate weight cluster is equal to parentheses FPC1 times FPC2, close parentheses, and invert that guy. So raise it to the -1 power or do 1 over that fraction. So now we've defined our finite population corrections and our weights, and we can survey set our data. To survey set data for a two-stage survey, we have to specify both stages of the survey, and in Stata you separate them using these two vertical bars. So on one side of the vertical bars, we have our first stage, which is sampling of the district. So there we would need to go ahead and plug in survey set, our district identifier, which in this case is just district. Next, you always just specify your survey weights. And after the survey weights, again, if you want to specify a finite population correction, we would say FPC parentheses and give it the name of our variable FPC1. And then double bars tells Stata, all right, we're going to the next phase of the sampling, the next stage. So the next stage is we sample people within districts. So after the double bars, put the identifier for the people in your survey data, which is ID. And then if you want to specify a finite population correction, we would say FPC parentheses FPC2. And now you survey set your data. What you see now is that we don't have any strata in our population, but it tells us what the sampling units are. The first sampling unit is district, and we have a finite population correction associated with that. The second sampling unit is ID, and there's another finite population correction associated with that. So it's taking into account the fact that we have both a finite number of districts and a finite number of people within districts. And it also has our survey weights taken into account up here. So again, we can just type survey proportion malaria, and we obtain an estimate of the malaria prevalence, which is 14.4%. So this is a little bit higher than we saw using the data from the simple random sample and the stratified sample. That's just by chance. You know, it just depends on what I did. I generated the sample by going and taking a cluster sample from a data set that I had created. So by chance, now we end up with a higher estimate of the malaria prevalence. Let's calculate our design effect as well. Now we find that we have a higher design effect. It's about 1.6. So typically when you conduct a survey, a cluster survey sample, it does inflate your variance. But the loss of precision that you usually have in cluster surveys is usually balanced out by the fact that you can save in cost. So really surveys are all about balancing cost with precision. What's the most efficient way to go out and sample people in your population?